This is for lesson 7-8 for interpreting graphs. You'll see here from this graph that's shown in this book, it shows time in minutes going across this way from 0 to 50 minutes. And then speed here, starting at 0 going up to about 25. And then what you'll see here on the left side is the color coded that goes along with these line segments here. So it says first the horse walks at a constant speed for the first 10 minutes. So it's showing from 0 to 10 minutes, the horse is walking at a constant speed. Then the next one in blue, shown here, its speed increases over the next 7 minutes. So that's showing the speed increasing from 10 to 17 minutes, which would be the next 7 minutes. Then it gallops at a constant rate for 20 minutes, so the line would go straight across at the constant rate for 20 minutes, from 17 to 37 minutes. Then you see it slowing down. So as it slows down, the speed is decreasing. And then it walks at a constant pace for 10 minutes. So there's some other examples here that you'll need to work on. There's an example up here at the top of your review for 7-8. And I'll do 2 example problems. It gives you the start of the graphs, or it gives you part of the graph with part of it missing. And then the last 2, you need to do the entire graph for the last 2. I'll show you 2 of them. So the first one here, it shows for temperature and time. So time going across, temperature. So as time goes across so far here, the temperature is remaining the same. It says you pour warm tea into a glass. So that's this showing it here. And then you're adding ice cubes. So if you add ice cubes to the temperature for this tea in the glass, you should be able to see that, of course, the temperature is going to start to gradually decrease. Okay, so your line should look something like that, sloping downward to the right over time, getting cooler. Let me show you one on the back. So this shows 3 different graphs that you need to choose from. Which one would be correct for this description up here? So the question says the gas tank in Karen's car was full. So starting with that information, you should already be able to eliminate one of the graphs. Because down here the graphs are showing time and then gas in the tank. This one shows gas in the tank as being here, which would not be full. These 2 showing at the top amount of gas in the tank. So you should already be able to eliminate option A, because this says the gas in Karen's tank was full. So graph A cannot be correct. So you'll focus now on graphs B and C. Karen drove the car until only 1/4 of the tank was full. So both of them are decreasing because over time, obviously gas in the tank, as you're driving, it's going to decrease because you're burning fuel. It's going to be decreasing. Both of these are doing that. So far, either of these could still be correct. Karen then filled up the tank again. So you should now be able to see which one is proper, because this one is going down, yes. And it says here that Karen drove it until it was 1/4 full. And then she filled up the tank again. So filling up the tank should be shown like this. This would be here showing that maybe she stopped here and then filled up the gas. So let's see which one would still be correct to make sure both of these look fairly accurate. And then she drove the car until 1/4 tank was full. So then again, the line goes downward. But there's an extra section here at the end. 1/4 of the tank was full. And then it doesn't say anything else after that. So I would go with letter C, because then over time her car's gas tank would remain the same if she stopped the car. This is tricky because this one shows it going down and then yes, it's going up as she filled it. But you could say that here she stopped, and then when she stopped to get gas, then she filled it up, because it doesn't automatically happen. It needs to stop first, and then the gas level goes back up.